to get started. All right. So as soon as it airs, this is going to go live on my YouTube channel. So for those of you guys that want to get access to this video or the replay, you can go catch this on YouTube. Let me make sure it's straight. Yep, we're good to go. Let me make sure I can hear. Yep, we got sound. So now I am going to screen share. And we're going to start with what you guys want to learn. So I know many of you all are thinking about the Regents exam, and that's where my focus is going to be today for the Regents exam, because I know several of you all are preparing for that. And I want to make sure that you guys are good to go. All right. So I know one request dealt with dimensional analysis. So I do have that information for you. And dimensional analysis just simply means conversions, okay? You're just simply converting from one thing to another. And it gets a little sticky when you have multiple things to convert to. So we'll go through that tonight. And I'm trying to find one example here that we could kind of show as an example. Because a lot of times students get confused as to what they need to do, like what step goes where and how and why. So I'm going to pick a question that we can actually do so that you're prepared to do a dimensional analysis. Okay, so I'm just trying to find a good one for you guys. Let's see here. Okay, so I tell you what I'm going to do. I am going to, let's see. I'm going to pull a stoichiometry question because that's pretty much what it is. It's stoichiometry. Okay, so let me go ahead and pull one up for you guys. Okay. All righty. So I'm going to start with one that's, fairly simple in terms of what you have to do. Okay. So let me see here. Okay, so I'm going to go ahead and switch my screen. Okay, so that way you guys can see this problem. So when it comes to stoichiometry, which is dimensional analysis, one of the things you guys got to remember is that you're simply converting from one compound to the next. Okay, so I'm going to zoom in so you all can see the problem. Yep. Okay. And there we go. And so now let me go ahead and break this down for you. Whenever you're given a problem, such as this nature right here, okay, we're going to focus on number 9.7. Let me zoom out a little bit. We're going to do letter A. And it looks like it's trying to refocus. Okay, there we go. So I'm going to do letter A, okay? And in letter A, they're asking you to uh, determine how many moles are required from oxygen to react with 2.0 moles of hydrogen. Okay, so this is the one that we're going to actually do for you guys. Now, of course, when you're doing problems like this, one thing you have to keep in mind is that you need to have a periodic table on standby in case you're having to do some conversions, okay? So you do need to have your periodic table on standby in case you have to do some conversions with these types of problems. Now, matter of fact, I'm going to go ahead and show you guys and make sure you all tap that screen so that the notifications can go out to TikTok world that Professor TK the Chemist is doing problems for you guys, okay? And that we're giving away free tutoring. So that's what this is all about today. All right, so make sure you all tap that screen, tap, 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 and welcome, welcome, welcome. Hello, everybody. Hey, Nomi, how are you doing? Hey, Vanessa. Thank you guys so much for tapping that screen. And we're going to go ahead and start on this problem. Appreciate you guys. All right. All right, so for this particular problem right here, okay, what we have, guys, it says how many moles of oxygen are required to react with 2.0 moles of hydrogen. One of the things you guys got to remember is that whenever you're dealing with a chemical reaction, that's the first thing you need. So I'm going to rewrite this problem out, okay, so that you all can focus simply on the information that is given, okay? Now, whenever it comes to dimensional analysis, you want to make sure that you can tell what's given in the problem and what's required. In this problem, they want to know how many moles of oxygen are required to react with 2.0 moles of hydrogen. Okay, so what you are going to focus on are the moles of oxygen and hydrogen. They did not say anything about water. So you ignore H2O. All right. So what I'm going to do is show you all the simplest way that you all can actually figure this problem out. Okay. So what you're going to do first, you're going to label this. Okay. They told you they want to know how many moles of oxygen. So I'm going to put an X above that. Okay. That's what we're looking for. We're looking for the moles of oxygen. What they gave you also was that there was 2.0 moles of hydrogen. So in other words, if the initial coefficient was 2 and then it stayed or remained at 2, correct the wild Rob, then oxygen is going to also be 1 because the initial moles for oxygen was 1. Now, for those of you all that don't quite see how to do this, what you're going to do is take the 2.0 moles of hydrogen, okay? That's the starting number right there, 2.0 moles of hydrogen. And what you're trying to get to, that's going to go on the very top, but it's the coefficient. So at this particular step, you're going to put 1 mole of oxygen right here on the very top. And on the, okay, again, that 1 mole comes from the coefficient right here for oxygen. On the very bottom, we're going to put 2 moles of hydrogen. And again, that comes from the coefficient here from your balanced equation. So now what you're going to do is simply cross out your moles of hydrogen, just like that, but you still need to multiply your numbers. So 2.0 times 1 is 2, and then divide that by 2 again, and you end up with 2.0 moles of oxygen. It's that simple. It is that simple. Hey, Ariana, how are you doing tonight? All right. Now, here's the other thing with dimensional analysis. Suppose we said how many grams of oxygen. Ariana, this is somewhat similar to reagents, limiting reagents. That's what we did yesterday. Wow, good job. Good job, Ariana. Good job. Fantastic. Fantastic. Good job. I love hearing that. I love it, love it, love it. So, if they ask you to give the grams of oxygen, all you would have to do is take that 2.0 moles of oxygen and simply multiply this times the molar mass of oxygen. Now, since there are 2 of them, you're going to look at your periodic table and find the molecular weight for oxygen, which is 16.00. So 2 times, let me put this over here off to the side. The molar mass for oxygen is 2 times 16, and you get 32, okay? So, okay, I got you. I'll do a limiting reagents problem tonight. Yes, you'll be next for that one. So you're going to put the 32.00 grams of oxygen on the very top, and on the very bottom, you're going to put 1 mole of that. And then you're going to cross out your moles and just simply say 2 times 32, that gives you 64.00 grams of oxygen. So again, with dimensional analysis, what you always want to keep in mind, okay? And I'll give you like a little formula that you can use for this problem. if I give you a problem where I'm saying I got moles of A and I want you to give me the grams of B, what you have to do is start off with the moles of A times, and right here, whatever the moles of A was from your balanced equation, you're going to put the moles of B on the very top. And then guess what you're going to do? You're going to cross out the units of the moles of each A, okay? And then you're going to go to the next part, which is to simply say, all right, moles of B on the very bottom, and then you're going to put on the very top grams of B. Again, you can easily cancel out your moles of B, if these were hypothetical numbers. So the thing you have to remember is that whatever you start with, like in this particular case, you want to put on the bottom so they can cancel each other out. And then whatever you're trying to get to and trying to, like, whatever unit you're trying to get rid of for the top should also go on the very bottom on the other side, so that you're left with finding the unknown unit. Okay, that's how these types of problems work when it comes to dimensional analysis. Now, on the other hand, let's say, okay, like I know Ariana said she wanted to do a limiting reagents problem, and that's something that we like worked on yesterday, but as an example, it still has the same concept and the same process. So I'll pull up one of the, hey Tally, how are you doing? Haven't seen you in a minute. So let me pull up a limiting reagent problem for you guys so that, I know that's another concern too when it comes to problem solving. Okay, so we'll go ahead and pull up one of those limiting reagent problems. Okay, so here's one that I did before. And I'm going to, again, help you guys figure this out, okay? I'm going to help you all figure this out. So let me go ahead and, yes, Nomi, I will do that one. Yes, 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 we'll do that one as well. Theoretical yield versus limiting reagents. Yes, 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 yes. All right, so let's look at this example here, okay? And even though I did it, I'm going to explain to you how to solve this problem. Yes, this one that I'm doing right now. Yes, it is. Yes. Yes, yes, yes. I did one like this before, but what I'm going to do is explain to you how to solve it, okay? So, what you've got, okay, in this particular problem, it says a 1.00 mole sample of iron 2 oxide is heated with 1.00 moles of aluminum metal and converted to molten iron. Identify the limiting reactant, okay, and calculate the moles of iron produced. So I'm erasing how I did it so that way I can explain it to you from top to bottom. First off, you're going to be given a balanced equation. That's one of the things you need to make sure that you do know, okay? Make sure the reaction is balanced. Then you're going to note what is given in the problem. So they gave you 1.00 moles of iron 2 oxide. So I'm going to write this above, 1.00 moles. They also told you that it was heated with 1.00 moles of of aluminum. Identify the limiting reactant and calculate the moles of iron produced. So, in other words, what you're trying to establish is which one of these compounds over here or elements, which one of these right here, okay, is going to be the limiting reactant. When we say limiting reactant, we're talking about either iron 2 oxide or aluminum. It's going to be what's on the left-hand side, okay? That's what they're asking you to do. So whenever you hear the word limiting reactant, always know you're trying to establish the reaction, one of the reactants, that's the limiting one. Now, what they are trying to do is get you to compare that to the moles of iron that's produced. So in other words, you're going to also utilize the iron part right there, okay? So what I'm going to do now, I'm going to simply say, all right, 1.00 moles of FeO times. Now remember, they were asking you about the moles of iron. So on the very top, I'm going to put 3.00 moles of iron because that's the coefficient here, okay? That's the coefficient right there. And on the very bottom, I'm going to look at this 3 right here and put that as 3 moles of FeO. And the reason why I'm using that one is because what I started with right here, the 1.00 moles of iron 2 oxide that they gave me, that's got to cancel out, okay? So now all you need to do is say, all right, well, 1.00 times 3.00 is 3, and then divide that by 3, and you get 1.00 moles of iron. Now, we're not done yet, because what they want to know is which one of these reactants is going to be the limiting one. In other words, the smallest number that is produced. No, man, I don't do any organic chemistry. Sorry. And thank you to the person that shared this with 5 or more friends, okay? I appreciate that. Thank you. Now, you're going to take the next number right here, and I'm going to highlight this next number in yellow, okay? So you're going to take this 1.00 moles here, and that's the 1.00 moles of aluminum. Now, remember, on the very bottom, okay, I'm going to put, from my coefficient right here for aluminum, I'm going to put the 2 moles right there on the very bottom, okay? Thank you, Kiki. Appreciate you. You're going to put 2 moles of aluminum on the very bottom, and on the top, we're going to still put 3.00 moles of iron, okay? That's from this coefficient here. So now all you're going to do is say 1 times 3 is 3, and then divide that by 2. So let's plug this in, okay? Let's plug this in. So you've got 1.00 times 3.00 divided by 2, and you get 1.5. Now, when they ask you which is the limiting reactant, you're going to note the one that produced the smallest amount. This is the smallest number, right? So the element, or the compound rather, that produced the smallest amount was the iron 2 oxide. That's how you determine which one is the limiting reactant. The one that produced the smallest amount. Okay? That's how you do that. The one that produced the smallest amount. See, it's quite simple. It's not hard, but I know it's easier said than done, right? Easier said than done. Good job, YT. Good job. Fantastic. You guys are super smart. I love hearing the good news that you guys share. I really do. I love, love, love hearing that. All right. So now I know you wanted to know about theoretical yield. So let me go ahead and find one of those also for you. Okay. So theoretical yield. And this is related to that topic as well. Okay. Theoretical yield is related to this. So with theoretical yield, okay, you're basically looking for the maximum amount of a product that a reaction can produce from a given amount of reactant. Okay, that's what theoretical yield is. It's the maximum amount of a product that a reaction can produce. Okay, from a given amount of reactant. So let me find a good example for you. Okay, so that you're able to do that type of problem. Thank you. Thank you, user. No, Ariana, this is the same thing. Yeah, this is the same thing. Because remember, with theoretical yield, okay, or limiting reactants, this is just simply telling you, okay, what they have to do in the problem. They have to give you two different amounts of your reactants, okay? So in other words, I'm going to give you two of these numbers right here. I'm going to give you the amount of iron 2 oxide, and I'm going to give you the amount of aluminum. You're comparing the results that are going to produce iron. And if they asked you about aluminum oxide, then you would compare aluminum oxide. But they were asking you about iron. How much of iron 2 oxide or how much of aluminum is going to produce the smallest amount of iron? And that's considered to be your limiting reactant. Okay? So, in other words, when we were doing the calculations here, we started off with 1.00 moles of iron 2 oxide. And on the very bottom, that 3 comes from the coefficient of 3 here from your chemical reaction. And the 3 on the top comes from your coefficient for iron. The next one they gave you was 1.00 moles of aluminum. On the very bottom, you have to write the 2 here for your moles of aluminum. And on the very top, the 3 moles of iron. Again, you're still comparing both of these compounds or elements to iron. And whoever produces the smallest amount, that particular compound is the limiting reactant. Okay, that's what we mean by that. Okay. Does that make sense, Ariana? If not, do you have another example or an idea of what you're looking for when it comes to this particular topic? If that doesn't make sense. And I'll let you think about that for a second. Okay, grab your study guide. Yes, grab your study guide. Yes, Naomi, yes, they're pretty much the same thing. Yes. Okay, Atticus, you said, can you do it when it's talking about aluminum oxide? I sure can. Let's do that one. Let's do that one. Okay, so while she's bringing her study guide back, we'll do the one if they were asking you about aluminum oxide. Okay, good deal, good deal. Now, here's what I want you to do. I want you guys to watch what happens when what I am erasing. Okay, so take a look. Because we're saying limiting reactant, the 1.00 moles that they gave you of iron 2 oxide doesn't change. The coefficient that goes with iron 2 oxide is 3. We're also looking for aluminum oxide. So those are going to be the only two numbers that we focus on for this particular problem. So right here, I'm going to write 1 mole of aluminum oxide. Now, 1 times 1 is 1, divided by 3, and you get 0.333, and it keeps going, of aluminum oxide. Now, on this next part, okay, what you're going to do, you're going to look at aluminum, okay? And before I move on to that part, I want to just show y'all again. The number of 1.00 moles is what we had in the problem. The 3 moles here and the 1 mole of aluminum oxide are from these coefficients here in yellow. Now, I'm going to go ahead and put this in pink now, the next part. We still have 1.00 moles of aluminum. And on the very bottom, we're still dealing with the 2 moles of aluminum. But on the very top, guess what? That number doesn't change. 1 mole of aluminum oxide. And again, that's coming from your reaction here, okay? So now we're using aluminum, comparing that to aluminum oxide. And guess what we're going to do now? Okay, yes, Jay, we'll do another one for you. Yeah, we'll do another one. 1 times 1 is 1, and then divide that by 2, and you get 0.5 moles of aluminum oxide. So now in this case, if you look at it, which one of these compounds is the limiting reactant? It's still iron 2 oxide because that gave us the smallest amount. So whichever element gives you the smallest amount is the limiting reactant. Okay, so you want to do another one. So sure, let's pull up another example. Okay, let me see here. Another example. Let's see if this will give us one right here. Yep. I think this is the one that I did yesterday. Yes, but I'll do one for you as well. Let me pick a good one right here. Mm, okay, I'm gonna pull this one right here. I'm gonna put this on the paper that we were just on right here. Okay. And by the way, if you guys want to watch the replay of this video, you can always go to my YouTube channel and you can see this on my YouTube channel, okay? No, that's okay. That's okay. No, mole is MOLE. It's the abbreviation for MOLE. So if I say a mole, that's MOLE. Molecule is simply molecule. There's no abbreviation for molecule. Yes, that's right. No, Nomi, very good. That's correct. Thank you, Yas Chels. Okay, let's do another one of these limiting reactant problems. Okay, so you've got iron reacting with oxygen to form iron 3 oxide, okay? Here's what you're going to do. You're going to, again, I'm just going to rewrite the formula or the reaction, okay? So that way I'm able to just compare the numbers here. All right. So in this problem, okay, in this problem, it says, and we're only looking at letter A, okay? We're looking at letter A. All right. So right here it says 2.0 moles of iron and 6.0 moles of oxygen. Determine the limiting reactant in each of the following mixtures of reactants. So in other words, they're giving you two different amounts of each element, but you're comparing it to iron 3 oxide. So let me show you how to do the first one, okay? The first compound that I'm going to focus on is iron, and I'm going to compare that to iron 3 oxide, okay? So I'm focusing on iron and iron 3 oxide. So what am I going to do? I'm going to label this one. They told us 2.0 moles of that, okay? So here's what you're going to do. Take the number that they start off with, 2.0 moles of iron times. Now remember, I'm going to put 4 moles of iron on the bottom because that's what they gave me in this problem right here, that 4. And then on the very top, the 2 moles of iron 3 oxide is going to go on the very top. Okay, so now all you're going to do is multiply. 2 times 2 is 4, divided by 4, and you get 1.0 moles of iron 3 oxide. Okay? No, Naomi, no. Theoretical yield, okay? Theoretical yield is when you have a reaction, it's the amount of product you would expect if all the reactants were converted to a certain amount. Okay. I'll do one like that for you in a second. After I finish this one, I'll do a theoretical yield problem. Yes, I'll do one of those. Mm-hmm. You're welcome. Now for the next one, we're going to compare. I'm going to change the color. We're going to now look at 6 moles of oxygen. Okay, and again, we're still comparing it to iron 3 oxide. Okay, Samira, I'll get your question in a second, okay? So what you're going to do, you're going to say 6.0 moles of oxygen times. Now on the very bottom, you're going to use a coefficient for oxygen. Because remember, this time you're comparing oxygen to iron 3 oxide, okay? So now you're going to put on the very bottom 3 moles of oxygen, and on the very top, 2 moles of Fe2O3. So remember, the top number still doesn't change. So now 6 times 2 is 12. 12 divided by 3 is 4.0 moles of Fe2O3. Now, again, if we ask you which one of these elements is the limiting reactant, you're going to say the one that yielded the smallest amount, okay, of iron 3 oxide. This one is the smallest right here. Therefore, iron is the limiting reactant. Okay, Carmen said, where did 3 moles of oxygen come from? 3 moles came from your balanced equation from the coefficient right here. Okay, no problem, no problem. I'll give you the question again so you can see it. Okay, so whenever you have, and again, we were only looking at letter A. Okay, we're only looking at letter A. So this is your balanced equation. Oh, you're welcome. This is your balanced equation. And what you have to do is to determine which one of these elements, the one that I highlighted in pink versus the one I highlighted in yellow, which one of those is going to produce the smallest amount of iron 3 oxide? So we took the 2.0 moles of iron and we converted it to the moles of iron 3 oxide. And we got 1.0 moles of iron 3 oxide. Then we took the 6.0 moles of oxygen and converted it to the moles of iron 3 oxide. And we got 4. So the one that gave us the smallest amount or the smallest yield of iron 3 oxide was the one that was for iron. So that element is the one that's considered to be your limiting reactant. Okay, Ariana, you got your question. And let me, while you're pulling it up, let me go back. Someone asked, Angel, I'll get your question too in a second. Okay, Samira said, how do we know the positive and negative charges on the periodic table? All right, for your periodic table, okay, most of your elements that are metals are classified as being positively charged. So 85% of your elements are considered to be your limiting reactants, okay? So let me give you an example. I'm going to pull up a periodic table so you can see that, okay? Let me see here. Let me give you a periodic table so you can see. So if we were to look at all the elements here on the periodic table, okay? I'm trying to get a good one. Let me see here. And hopefully, okay, there we go. So if you look at your periodic table, it goes +1. Group 1 has a +1 charge. Group 2 has a +2 charge. Groups 3 through 12 are all positively charged, but they have random charges. Group 13 has a +3 charge. Group 14 has a +4. Then it goes backwards. -3 for group, whoops, sorry, you couldn't see the screen, I'm sorry. Group 15 has a -3 charge. Group 16 has a -2, -1, and 0. So it's basically like a numbers chart, positive to negative. Thank you, Samara. Yeah, this video is actually on YouTube. So if you want to go back and look at it again, you sure can do that. I don't have any notes or anything that you can actually copy, but yes, this video is live right now on my YouTube channel. And make sure that when you guys go to my YouTube channel, that you thumbs up the video and watch at least, 10% of it so I can get the credit, okay? That people to let people know that they are still watching them. Yes. So I have all these videos when I go live. They're all on my YouTube channel. Okay, let's see here. Ariana, what is your question now? And you did ask about theoretical yield. And I wish I was able to get your question like I could, come out and go back in so that I could see what you needed help on, but we don't even have that technology yet in terms of, going out and coming in. Okay, I got you. Okay. Okay. Okay, let me write that down. Okay, Angel. Well, guess what? If you're taking, I know you had asked about General Chemistry 1. Are you taking this during the summertime? Okay. So let me see if I can pin your question, Ariana. Let me see. Hold on. Let me see. I'm still pin this comment. Okay, so let me write that one down. So I'm going to actually come out of this screen right here. Okay. And let me go back here to, I'll go to this blank screen right here. Okay. Okay, so here we go. So let me write that question down. Let's see here. It was, and this is a long reaction. Why would your teacher give you this? Oh my gosh. I'm just going to write it like that. Is this even right? Okay. Because I was going to say this is a combustion problem, but now I'm like, nah. So this is what you wrote. I mean, let me see. And I hope it's balanced because otherwise we're going to take forever to balance the equation. Let's see, 3, 4, 6, 7, 8, 8. 4, 6, 7, 8. Okay, yeah, this is a okay, you copied it wrong. Okay. That's okay. That's okay. That's okay. Is this a theoretical problem that you're looking at? Because I can pull one. Okay, that's okay. Because I can actually pull one from my book, while you're getting the one that you want me to do. Okay. So let me give you all one that I have right here. Okay. So we've got carbon monoxide, okay, plus hydrogen gas that produces, of course, CH4O. Okay, this is the chemical reaction. All right, and I'm going to read it to you, okay? If 3 point, and I'm just going to write down what's given. If 3.00 moles of CO and 5.00 moles of hydrogen are the initial reactants, what is the limiting reactant? And how many moles of methanol can be produced? Okay, so let me scroll this up, okay? And the number of moles of CH4 can be produced. Okay. Yes, thank you. Okay, so okay, give me a second, Jay. Give me a second. And I will user 927. Yes, I will keep on doing it. Thank you guys so much for the hearts. We got another TK. All right. Okay, so I'm going to rewrite your equation. Let me make sure that we had it right. Okay. So I'm going to go back to the one that you had. C7H6O3 plus CH3. Okay, let me let's see, H3 OH C8H. Okay, this is the form. Okay. And a food scientist starts with 1.75 grams of salicylic acid and 1.53 grams of methanol. Okay, so they're telling you 1.75 grams of this one and 1.53 grams of that one. How much methyl silicate is produced? So they want to know about this one. Okay. Okay, yes, Jay, I got you. Okay, Mrs. Fayez. Okay. Hey, how you doing? Okay. So now, in a problem like this, okay, I'm going to erase what I was getting ready to do. So let me go ahead and erase that part. Okay. And let's try to do this problem. Now, this is going to take a little time, and you know why? Because for this problem, based on what you've written, we've got to convert these grams to moles, okay? And that's going to take some time to do. So if y'all got time, okay, be patient. Because in this particular problem, they want to know how many grams is produced for this particular one. So what we would have to do first is take the 1.75 grams of C7H6O3 and convert that to a mole. And let me tell you this too. This reaction is balanced, and let me tell you why. We've got 8 carbons on the left, 8 carbons on the right. Let's see, we've got 10 hydrogens on the left, 10 hydrogens on the right, 4 oxygens on the left, 4 oxygens on the right. So this is balanced. That's the first thing you want to make sure that's done, that is balanced. Now, because we've got this 1.75 grams of C7H6O3, we've got to first convert that to a mole. And if you all remember, you have to find the molar mass of this entire compound. Now, Ariana, do you have the molar mass by any chance? Okay, you said, why do we convert to the one on the far right instead of the water? Well, because they're asking you about this one right here. They want to know how much of this is being produced. So we don't care about water. Okay, thank you, Ariana. Now I'm banking on your number 138. Okay, because of time, I'm going to bank on your number of 138. So the way she got 138, she said 7 times 12.01 plus 6.06 for hydrogen plus, and you've got 3 oxygens times 48. Okay, and you get, yep, 138 is correct. So 138 on the very bottom right here, grams of C7H6O3. Now we're going to cancel out again the grams because we don't need those anymore. And what we're going to get here are the moles, okay? So we're going to end up with 1.75 divided by 138. And we get 0.0127 moles of C7H6O3. Now, we're not done because in this particular problem, what they want you to do, let me zoom out a little so you can see the whole screen. What you have to do here is you have to take those moles and convert it to the moles of what I circled in pink, okay? So you're going to take that 0.0127 moles of C7H6O3 times. Now remember, we are trying to get our mole to mole ratio here, okay? Since we are trying to figure out how many moles of this reactant is being produced as highlighted here in pink, we're going to put that number on the very top. We're going to say 1 mole of C8H8O3. Now, on the very bottom, we're going to go back to our coefficient of this one right here, okay, which is still 1 as well, okay? So on the very bottom, I'm going to put 1 mole of C7H6O3. Now, 0.0127 times 1 divided by 1 still gives you 0.0127 moles of C8H8O3. Now, I'm going to let that breathe for a second before I finish, okay? So again, let me just tell you what I did for the first part. This problem takes a long time, okay? So again, this is your chemical reaction. And they gave you 1.75 grams of C7H6O3. They also gave you 1.53 grams of CH3OH. They want to know how much of this C8H8O3 is produced from either of these compounds. First thing I had to do was go from grams of C7H6O3 to a mole. And then from the moles of what I just found for C7H6O3, I then do the mole to mole ratio for C8H8O3 because I'm trying to determine how much of that is going to be produced. Now, we're going to do the next one. I'm going to put that in a different color so you can see the variations, okay? So this next one right here, the one that's in yellow, I'm going to compare that number to this one still, okay, the C8H8O3. But in order to do that, I've got to find the grams of this converted to the moles, okay? So, Ariana, I need you to give me the molar mass of CH3O8, okay? So, right here, I'm going to take 1.53 grams of CH3O8, okay, times, thank you. On the very top, 1 mole of CH3OH. And on the very bottom, you got 32. Okay. Again, how she got that? We got 1 carbon, which is 12, plus your 4 hydrogens. So 12 plus 4 is 16, plus 16 for your oxygen gives you 32. Now, we're going to get rid of the grams. Boom, boom. There we go. Of CH3OH. And now we're going to divide that. 1.53 divided by 32. And that gives us 0.0478 moles of CH3OH. Now remember, we've got to now compare that number to the moles of C8H8O3. Okay, so 0.0478 moles of CH3OH times. You're going to go back to your balance equation and you're basically going to write this coefficient right here. What I'm highlighting in yellow, you're going to put that on the very top right here. 1 mole of CH3OH. And on the very bottom, you're going to go back to your balance equation to look at the coefficient, which was still 1 right here. There's an imaginary 1 right there. Okay. And not that one, guys. This formula right here is the one that we wrote up here a second ago. The C8, that one, I'm sorry. You're going to write C8H8O3 right there. My bad, y'all. Okay. And then you're going to cancel out your moles here. And now you end up with multiplying 0.0478 times 1 divided by 1, and you get 0.0478 moles of C8H8O3. So, whew, this one took forever. Oh my gosh. But if you look at these numbers here with all this stuff that's written, okay, I'm going to highlight these numbers in blue. This number compared to this number right here, which one was the smallest? Which number is the smallest? A or B? A or B? Right, Ariana, 0.0127. Therefore, the limiting reactant is C7H6O3. All of that to get to the limiting reactant. I need to take a drink of water, a sip of water. Woo. All right. Does that answer your question, Ariana? Do you have the answer key? That's my question too, Jay. Woo. Thank you, Tay. You got 1.75? Okay. Now, how did you get 1.75? Because 10th grade, this regular chemistry, your chemistry, okay, I don't want to talk about another teacher. However, this is like an honors type question, an honors chemistry question, because you're dealing with this right here, C7H6O3, like even though numbers are numbers and compounds are compounds, this one took, a little longer to do. And if you're doing this on a Regents exam, you don't have time to do something like this. Like, you see how long it took me to do it. So now imagine how long it would take you to do it. Not trying to say that you all can't do it, but teachers, if it takes us, let's say 5 minutes to do a problem like this, it would take you guys double this amount of time. I know, right, Grace? Right. But like JTBC8 says, keep up the good work because you can do this. I have faith in you guys. If you've been doing everything that you're supposed to do throughout the entire semester, the Regents exam is just going to test your knowledge base. And of course, they throw out certain questions. Some of the questions that they give you are test questions where it doesn't count, but you don't know which ones they are. Oh, okay. Yeah, see, you got to get that number right there, though. You got to first get the moles of that. So when you took the 1.75, yes, well, and even still, but did you divide those two? Because if you did, then you would get 0.0127. Okay, good job, Grace. Thank you, JTBC. Appreciate you. Okay, okay, okay. Now, where'd you get 152 from? See, because you didn't need 152 for this problem. You only needed the molar mass for C7H6O3, and you need the molar mass for CH3OH. Okay, yeah. Yeah, so you didn't even need to use C8H8O3. Yeah, you didn't even need to use that number. And so I see where you got the 152 from now, because you got the molar mass for that. So for those of you all that don't know, let me show you. So 12 times 8 plus 8 again for your hydrogens plus 48 for your uh oxygens. And that's how she got 152. Okay, go back to my YouTube channel again when you do this. Did she give you the answer key, Ariana, like so you can check yourself? Or is this a problem that you have to do for homework? Because if you got the answer key, I want you to look at what I did. Go back to my YouTube channel. Okay, okay, good, 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 good. Jay, are you still here? Because I know you asked me to do a problem. Ooh, Grace. Equilibrium, Le Chatelier's principle. Okay, so here is the deal with Le Chatelier's principle. Okay, so I actually have some videos on that too. Okay, good. So Grace, you hold tight for me, honey. I'm gonna take care of Jay real quick because Jay asked me a question earlier. Which question are you talking about, Jay? Remind me of which one you wanted to go back to. You said letter B. Um, let me see. Okay, so let me go back to letter B. Okay, right, right. Okay, let me see if this is the one right here. Okay, so let me copy that one out and let me do that one. Okay, I'll do that one. Matter of fact, let me see if I can just pull the answer real quick. And I can tell you if you got it right. 2.6. Okay. The reaction. And then 2.5. Okay, yeah, I'm gonna point it out in my book. That way, yeah, that way you can see if you got your answer right. Um, so I'm gonna show it to you in my book. 9.7. Okay. Yes, this is the let me zoom in a little bit. And Jay, I want you to tell me what did you I zoomed in too much. Okay, that's B and that's C. What did you Okay, you said you don't think this is it? But are you sure? Okay, let me see. Was this the one right here then? Okay, gotcha. Let me screen share. Okay, let me do that one. Okay, I just pulled it up. Yep. 9.22. Okay, okay, no problem. No problem. This is the one right here. Hey, Mihawk, how you doing? Okay, so let's do this. Was this the one, Jay? Okay, that's it. Okay, so let's do that one then. let's see. I'm gonna take this one out and I'm gonna put it down here. Uh, okay. All right. So again, you got your balanced equation. Now, I left off the physical states, y'all, just because I'm going to do letter B. So what they're giving you is 5.0 moles of iron, and they also gave you 4.0 moles of oxygen. And you're comparing that with iron 3 oxide. Okay, so for this one, you should say 5.0 moles of iron, because that's the first one that we're going to do, times. On the very bottom, you're going to use a coefficient here. Okay, you're going to use that 4 for the bottom right here. So I'm going to write 4 moles of iron. Okay, and on the very top, I'm going to use this coefficient here. So I'm going to write 2 moles of iron 3 oxide. And now 5 times 2 is 10. And then 10 divided by 4 gives us 2.5 moles of Fe2O3. That's the first part. Now we're going to do the same thing with the other number that they gave us, which were the 4 moles of oxygen. So we're going to compare this coefficient here on the very bottom. Okay, so I'm going to take that same number here. This time, I'm going to say 4.0 moles of oxygen times, and on the very bottom, I'm going to write 3 moles of oxygen. Again, that's coming from this coefficient right here. And on the very top, the 2 moles of Fe2O3. So 4 times 2 is 8. And then divide that by 3, you get 2.67 or 2.7 moles of Fe2O3. So now, Jay, my question for you is, which one of these numbers is the limiting reactant? Which one would you say? Is it the 5.0 moles of iron or the 4.0 moles of oxygen? Which one is the limiting Okay, very good. That is correct. That is correct. The one that produced the smallest amount is the limiting reactant. That is correct. Okay. All right, guys. So, Ariana, did you get your question? You're welcome, Jay. You're welcome. Okay, gotcha. All right. Okay. So while we're waiting on Ariana to come back, does anybody else have any more questions before we get off? Okay, you're gonna copy C. Okay. All right, go right ahead and copy C. And you tell me what you get. I'm gonna do it not on the screen. Right. So you can do right. And that's what I was gonna say. Okay. Oh, Le Chatelier's principle. I got you. Yes. Okay, and Jay, I'm almost done with this next one because I'm doing it real quick so that you can check yourself too. Okay. Well, all right. When you find it, DM me your question, your answer, so that way we can make sure that we got it. Okay. Yeah, DM me your answer. Okay, Jay, the answers to letter C, I'll put it down here. And Grace, if you can also see I have the problems on the Chatelier's principle on my YouTube channel, but I also have them here on TikTok too. And they're organized so you can actually go back in and kind of look at the playlist and it'll show you some examples. You're welcome. Okay, so Jay, there's your answer right there for letter C. Okay, letter C, that's your answer right there. Thank you, Darlena. All right. So with Le Chatelier's principle, Jay, let me know if you got it because I'm gonna go ahead and switch my screen up really quickly. I got 5 minutes. Okay, y'all, 5 minutes. Okay. And Jay, DM me, let me know that you got the answer correct, okay? In case we're not on once you do it on your own, okay? And oh, screenshot the question in case you forgot it. Screenshot this now so that way you'll have it. You're welcome. You are so welcome. Okay, good. Good, good, good. Okay. It's okay. It's okay. All right, let me see. Le Chatelier's principle. Let's see. Le Chat. Let's see. Mm, I'm gonna see what pops up. Okay, so let me switch my screen. Okay. Oh, I actually put this. Oh, thank you, Jay. I appreciate you. Oh, good, Darlena. Yes, 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 yes. You guys make sure you all come back, come back, come back. Thank you. And you enjoy the rest of your evening as well, Jay. Appreciate you. So, and you guys can go back and watch this video as well. And it's on my YouTube channel. I don't edit them, so you get it raw with all the mistakes and everything, all the comments. Yep. And you can yes, and my YouTube video, the YouTube channel is in my bio. So if you click that link, it'll take you straight over there to my YouTube channel. Learn chemistry with Professor TK the Chemist. Yep, learn chemistry with Professor TK the Chemist. And I go live Monday through Thursday at 7 p.m. Eastern Standard Time. So, Grace, I did several of these problems here with Le Chatelier's principle, but there is one in which I actually went over this chart. And because you're welcome, Darlene, I appreciate you. Because I am running out of time, what I'm going to recommend that you do is if you go in and you see um, this chart, I actually did several examples on how to determine like what the conditions are and what the values would be for them according to those conditions, like how it would go to the reactants, if it would favor the reactants, or if it would favor the products. So I actually went through this on my on the TikTok channel. So you can go through the playlist and see this here. And I also talked about how if you add reactants, the reaction is going to go forward. If you remove the reactants, it's going to reverse. So I actually went through this chart. And so you can actually go through them, Grace. And I did some examples. And all you have to do is look at the number. And the number will tell you whether or not it would go. You know, the KC value will indicate that. Yep, based on what you got. So you're welcome. Yeah, so as you can see, I did a lot of these problems already. And so that's what I would recommend that you do is go check out these solutions on my YouTube channel, and you can find the solutions and the way I did them and everything. Yep. And I'll be back tomorrow, guys. So if you all want to hop on with me tomorrow, I'll be back on tomorrow and go through these problems as well. Okay. So don't forget to tap in with me tomorrow. And you guys have a wonderful rest of your evening. And I look forward to seeing you guys tomorrow. And if you haven't, okay, what time? 7 p.m. Eastern Standard Time. Yes, Ashley, 7 p.m. Eastern Standard Time. Yep. I go live Monday through Thursday at 7 p.m. You're welcome at 7 p.m. Okay. So I appreciate you guys. Oh, why not, Grace? You can't join. Okay. Well, yeah, I tell you what, just DM me. If you got more concerns, Grace, DM me. And that way I can kind of address your concerns that way. Okay. All right, guys. Well, you all have a great rest of your evening, and I will see you all tomorrow. Oh, a sporty thing. Okay, I got you. I got you. The Regents exam, the pink rose, the Regents exam is what most students who are in New York take. I'm at the end of the year, like I'm in North Carolina, and our students took what's called the North Carolina Standard um, course exam or EOC, and the students from New York, they're still in school. Their Regents exam is basically the end of year exam for those subjects, whether it's history, math, science, and so forth. All right, guys. So you all have a wonderful rest of your night, and I will see you all tomorrow. What's your question? Okay, YouTube, I'm ending.